Welcome back everyone to our final video here in section 2 of chapter 2. In this video we're going to be taking a graphical viewpoint. So our main goal is that if we're given a graph of a function, we want to be able to sketch the graph of its derivative. And the claim is, well, we saw that at the beginning of this section, the first video, I showed you a picture like this. We saw that actually computers are quite good at this game, right? So we went ahead and we had the graph of a function, and then we were able to graph its derivative at a bunch of points. And then those collection of points there became the derivative function. Now, on homework, on quizzes, on exams, right, we will not have calculators or computers to help us. But we still want to be able to pull off this same sort of trick. If we have the function, can we sketch the function's derivative? So that is going to be our goal for this video. And so a kind of example that we're likely to see is something like this here, right? So given the plot of each one of these functions, sketch their derivatives. So I have this function here, and I would like to be able to sketch its derivative. So the claim is that there is a kind of a technique that we can follow in order to be able to do this. So let me give you the technique back up here. And it goes like this, is that some derivatives, right, are easier to take than others. So the ones that I have an easy time identifying is when the derivative is equal to 0. So in fact, kind of let me jump back and forth, maybe demonstrating on this example a little bit. So staring at this function right here, can you tell when the derivative, aka the slope at a point, is equal to 0? And so staring at this for a second, I get here at 3. Right? So at 3, if I was to kind of draw a mini little tangent line right here, you can see that that tangent line is horizontal, right? It has slope 0. So now I'm going to go ahead and plot this over here. So at 3, the derivative is 0. So I'm going to go ahead and give this height 0 right there on the x-axis. Next up, so the second step, determine the intervals where f of x is increasing and where it is decreasing. At those points, well, when it's increasing, right, the derivative will be positive. Increasing means it has positive slope. Well, slope is the same thing as the derivative. Likewise, when it's decreasing, the derivative will be negative. And now since we're going to be mapping this onto y values, right, positive y values means it's above the x-axis, right? Positive y values up here. Negative y values means it's below the x-axis, so it's going to be below the x-axis there. All right, so we can see maybe from 0 to 3, it looks like the function is decreasing. So therefore, I know the derivative will be negative, so the picture should be somewhere down here. Let me just go ahead and sketch. We know that the derivative should be somewhere down here, from 0 to 3. Because it is decreasing, the original function is decreasing, the derivative will be negative, which means that we're going to map it here below the x-axis. Now after 3, from 3 and beyond, right, we know it's going to be positive because the slope is, because it's increasing, right? So we see that the function is increasing, it has positive slope, so therefore after 3, we know it's going to live somewhere up here in the positive y values above the x-axis. All right, so the final step is to estimate the instantaneous rate of change, or the slope at a point, or the derivative, right? There's lots of different ways to say the same thing, at select points on each one of these intervals. So select points on each one of these intervals. So, okay, I'm going to go ahead and maybe estimate the derivative here at 1. So at 1, if I was to go ahead and maybe sketch this tangent line, I'm using purple here, we can see indeed the derivative is negative. If I was to continue this out to try to figure out the slope, I would say that the slope is around -1, right? Because for when I move over 1, I go down about 1. So again, rise over run. So I would say this is around -1. So okay, I'm going to go ahead and map here. This will be -1. And so at 1, the derivative is -1. Okay, let's do another one here. Select points on each interval. So I'm going to go ahead and choose the value 5. 5 seems like, again, a kind of nice one here. So if I graph its tangent line to try to get the derivative at this point, in this case, again, we know that it's already going to be positive. You can see the slope's increasing. And again, I see kind of as I take a step over to the right, it seems like I go up pretty darn close to 1, right? So, okay. So at 5, the slope seems to be, slope seems to be 1, right? Rise over run 1. So, okay, we get something like this. And now once we have a few of these points, right, I could do more of them. Maybe I'll do one more just for fun, right? So let's do at 7 here. So at 7, we'll go ahead and try to sketch the tangent line. Something like that. And we see as I take a step to the right, how much do I go up? Well, I would say that I go up around 1.5-ish, right? It's not exact, but around 1.5-ish. So again, this was 1, so here's 2, so here's 1.5. So at 7, we go up around 1.5, something like this. And now we just connect these points, kind of just like we graphed functions in the old days. Right, so we connect these points. And this is not exact by any means, but it is a good approximation. This is, right, we're not computers or calculators, so this is as good as we're going to get. Okay, I have one more example here for us, kind of a more complicated example. I'd like you to go ahead and take a shot at this on your own. So pause the video for a minute or two, get as far as you can, and then I'll go ahead and spoil the surprise. All right, let's go through the steps then together and verify your answer, hopefully. So the first thing I want to do is figure out when the derivative is equal to 0. So to me, staring at this graph right here, it seems like we get horizontal tangent lines. That's when the derivative would be equal to 0 at 2 and at 5. Okay, so at 2 and at 5, we're going to do height 0. And there we are. Next up, this kind of breaks up the graph into intervals, right? The numbers that are smaller than 2, then between 2 and 5, and then from 5 and bigger. So on each one of these intervals, I want to figure out, is the function increasing or decreasing? Because that's going to tell me, is the slope positive or negative? So in this case right here, from 0 to 2, it seems to be increasing, which means that the slope will be positive. So we know our graph's going to be somewhere up here, again in the positive y values. Next up, from 2 to 5, we can see that the function is decreasing. It has a negative slope, and therefore those negative values will lie here below the x-axis. And then after that, from 5 and bigger, it looks like the function is increasing, right? It has a positive slope. It's going up. So therefore, that positive slope, well, positive values are above the x-axis. So something like this. So this is where our functions should lie. Now we're going to go ahead and choose some test points kind of in each interval and go ahead and calculate or approximate really the slope at these values. So, all right, let's try here at 1. So if I go ahead and try to sketch my tangent line, something like this, well, notice for a step that I go over to the right, it seems like I go up about 0.75, maybe 0.8, really. Right, this is an approximation, so if this is 1 here, I'm going to say that we're going to go up, 0.8. So I'm going to do something like this, maybe. Kind of close to 1, a little bit less than that. So again, at the x value 1, we can see the slope at this point is around 0.8. Next up, somewhere between 2 and 5. All right, I'm going to go ahead and choose 3, but you could have chosen the x value 4. Doesn't really matter. This is just an approximation. So let's go ahead and draw the tangent line at this point. Something like this. Not my best tangent line ever, but all right. So we can see for a step over, we seem to go down. It's certainly less than a half, right? So we know that the derivative is negative there. It seems like it's going down less than a half, maybe like 0.3 or so. So okay, if this is now -1 at 3, it seems to have a slope around negative maybe 0.3 or and maybe negative 0.4, and maybe negative 0.25, but again, this is just a sketch. All right, now how about at 7? Right, 7's in the values that are bigger than 5. So at 7, let's go ahead and sketch the tangent line, something like this. And notice for a step over, we seem to go up, I would say pretty darn close to 2. Really a nice even 2-ish. So okay, let's go 2, and at the x value 7, the slope is 2. So something like this. All right, now let's go ahead and connect these points. I'm going to do something like this, down, and it kind of comes back up, and now up here, and maybe it kind of continues, again, kind of staying in these purple regions. But there would be a good graph of the derivative. And actually, this one looks pretty similar to what we had in our Desmos graph. Right, so if I go ahead and bring that up again, notice we had something that went up and then down and then up, and we had kind of almost this parabola looking thing. And this is pretty darn close to what we have here, right? It goes up and then down and then up, right? And our answer is sort of this parabola looking thing. All right, that is the final example, and that's it for section number 2. I'll see you guys next time when we learn some kind of quick rules and tricks to be able to calculate out the derivative very quickly. See you then.